So we are talking about artificial intelligence. Artificial intelligence meets payment behavior. So, and how could you benefit from untapped potential? So in the age of artificial intelligence, unused data equals an untapped goldmine. So we've talked about data science today, and now let's have a look what artificial intelligence could do for us, the utilization of artificial intelligence in the field of payment experience. So I'm happy to have my colleague here, Dr. Niklas Frerich, and yeah, maybe you could introduce yourself and yeah, let us see what your insights are.
Excellent. Well, I'm Dr. Niklas Frerich. I'm working at SCHUMANN on AI-driven topics, and today I want to give you, let's say, a real hands-on experience, what you can do using AI with payment behavior. I think the potential of AI nowadays is immense, as can be seen if you look around in everyday life. There's nowadays such things as self-driving cars or facial recognition software and all these kinds of things that appear to be sci-fi maybe 10, 15 years ago nowadays are real. And I want to show you how you can use AI to benefit from your untapped potential. So let's first have a look. Just have to grab the other one. Okay, excellent. Sorry about that. So first, let's have a look at AI and machine learning applications, or what AI is. AI and machine learning, these words are often used synonymously. And there's an often used definition of AI, which is AI leverages computers and machines to mimic the problem-solving and decision-making capabilities of the human mind. So we try to reproduce what the human mind can already do using computers. And how can this be achieved? Well, first of all, there's two approaches, supervised learning and unsupervised learning. In supervised learning, there's a given data set that you use for training the machine where you know the answer to a certain question. For example, you know the default status of a company, and you have some data related to that, and you can train a machine to predict future defaults of other companies. The other case, unsupervised learning, is methods where you have no specific question in mind while training the machine, so you don't need to have a specific answer. So what you do is you try to find patterns in your data. You try to automatically identify these patterns using machine learning, but you don't necessarily need to know what kind of pattern you're looking for. Supervised learning is used for such things as predictions or fraud detection even, or process optimization, while unsupervised learning is used for things like structure discovery or customer segmentation, among others. And if this was not detailed enough for you, let me give you one more example. Let's say you want to do a financial statement analysis using artificial intelligence. You can use your financial statement data, combine it with default data, and then train a neural network to actually get credit rating, right? And this already has been implemented at SCHUMANN, of course, and this is still working just fine, and we're trying to find out how we can now improve this even more. And always, if you try to improve something, you have to ask yourself, what is a possible challenge that we can overcome? In this case, I want to talk about the challenge called data time lag. And what does this mean? Let's say you have a credit application in the year 2016 and you want to use a data-driven approach, so an AI, to answer the question, should we approve this credit application or should we not? Then what you have as a data source is you have the financial statement from 2014, probably also have the financial statements from the years before that. And then you can analyze these financial statements, and we can, of course, do a trend analysis on this, and then we can decide, okay, this credit application is approved. And going forward, every year we can do the same, can keep using this financial statement data. However, let's say in the year 2021, we arrive at the question, we have credit application. Is the data from 2017 to 2019 really relevant to answering the question, can we approve this credit application or not? Because as we all know, a big crisis hit, and the crisis is arguably still ongoing, and it is really hard to tell if a company stayed the same or changed trajectory during this crisis. So then the question is, of course, how do we overcome this time lag challenge? And as you can, or I probably imagine from the title of this talk today, my answer to this question is we can overcome this challenge using the full potential of payment data. Payment data, of course, is very close to the pulse of the time. It is very granular, and it gives you very quick insights. You can see already small changes, and you can react to these changes, and thus use this data to overcome this. Therefore, we at Schumann decided to go the next step, and actually show you how you can benefit from payment data using AI. And to do this, the first thing we did was establish a data set, because every AI model is only as good as the data that you use to train it. And we analyzed this data and started by training a general model. We did this in collaboration with some of our customers, so this is real data that is actually relevant to the topic. When we got the data, we included 4 different data sources, 6 years of customer history, so debtor history, each of these data sources. That's over 15,000 different customers or debtors, and over 2.5 million unique sets of payment data that we use here in training. And on the right, you can see the payment target deviation, so the difference between the due date and the actual payment date for all the customers in the set. And then you can see the amount of invoices that have a given payment target deviation. You can see this colored by the 4 different data sources that we acquired the data from. And you can see, of course, these are customers that are already using the CAM system, so the credit management is already looking pretty good. But you can still see some differences in the data for the different sources. And this is good, right? We need this flexibility, we need this diversity in the data set, so we can train a data set that can, or train a model that can later be used to make good statements for new data or new questions. And to stress this point, this is data that we got from our customers. This is data that you have in your systems, and using this method, you can benefit from the potential of your own data. You already have this data, just need to tap it. So going forward, how did we proceed? Of course, there's a variety of information that's available in payment data, and you have to form a set of KPIs if you want to do any kind of analysis and training. We decided to divide this into 4 sets of KPIs. The first one is KPIs representing the short, medium, and long-term payment trends of the customer. So the question, in the short term, did the customer pay on time? Did the customer pay regularly on time? And compare this to the long term, maybe there's a difference, and so on. Then we have KPIs representing open invoices. This is very interesting because you might have a customer that in the past always paid on time, but now there's an invoice that's already open for 100 days or more, and then you need to take action. Third, and this is very interesting, is KPIs representing payment behavior relevant to this invoice's value. This might sound a bit complicated, but basically what this means is if you have a customer who had a bunch of invoices for 100 euros each and always paid them on time, and then there were a few invoices for several thousand euros that were paid late. Of course, for a general view on this customer, the invoices that were paid late for several thousand euros should reflect in the rating. However, if you look at a certain new invoice, and now there's a new invoice of this customer for 100 euros, if you want to just make statement for this invoice, then it's probably more relevant to look at the other invoices that were also about 100 euros. And this is what these KPIs are for. Lastly, we have KPIs representing dunning information. I think this is very obvious why this is important. If a customer went through the dunning process in the past, then it should be reflected going forward. So using all this information, we then trained an AI model, and the task of this model was to predict payments, or more specifically in this case, predict the payment target deviation. So how much days off is a customer from the due date. And here you can see the result, the performance of this model. So what you can see here is the comparison between the predicted payment target deviation and the actual payment target deviation. What you can see is that for the 75th percentile, we had a maximum error of 4 days, roughly, and some other values. And on the right, you can see that most of the invoices really have a very, very slim error. And there's very few invoices that have a larger error than this. In the mean, this means that we have a mean absolute error, so plus minus 3.8 roughly. So you can say that within a week, we can predict when a payment is incoming. And if you look, of course, at your whole portfolio, then you can improve your cash flow. You can improve treasury by just predicting incoming payments with using this method. Now, while this is already really good, the next step was to use clustering methods. So that's the unsupervised learning that I mentioned earlier, to have an AI find patterns within this data, right? And we fed all our data into one of these clustering methods. And now I just want to visualize for you what the result of this was. So here you can see every dot is a single invoice. And for every invoice, you can see on the bottom the mean payment target deviation of this customer that the invoice belongs to in the last 3 months before the invoice. And on the left, you can see the variance of that. So that means dots that are very low are very regular paid invoices, and dots are very high that are very inconsistent, right? And on the left is very early payment, and on the right it's very late payment. And just to give some more perspective to this, here you can see how many invoices or how many payments are within one cluster. And you can see even though the blue and the green cluster look very small compared to the rest, this is just due to them having a very high density of invoices. And actually, the blue and the green clusters make up the most percentage of all the data points, right? So we have roughly 2 million data points within these two clusters. What I find particularly fascinating about this analysis is this is just an AI that did some clustering on the payment data. We did not give it any hints on where to start looking for clusters, and still it came up with clusters that, if you think about it, you would also assign as a human, right? So using just my human mind, I just gave them some names, right? These clusters. Let's say the blue cluster is on-time payment, the green cluster is discount payment, and so on. But you have to keep in mind that these clusters were found by an AI that does not necessarily have an understanding of the real world, but it can still be intelligent and find these clusters on its own. And this means that you can use this method to intelligently sort all your customers, your whole portfolio, into clusters of similar payment behavior. And we can go even further. If you look at one particular customer, right, you can see here the payment target deviation of this customer and all the invoices from 2017 to 2022. You can see that in 2018, 2017, in that region, the customer always paid quite early, so probably took discount. And in 2019, it was more of a on-time payment. And then the crisis hit, right, in the middle of, or in the, when we went from 2019 to 2020, we had the crisis, and then the payments were very late. After that, it was quite inconsistent, and then we went back to, let's say, still somewhat inconsistent, but closer to on time. And the interesting thing here is this customer changed payment behavior over time, obviously. And if we use the clustering approach that I showed earlier to actually look at this data, then we can see that the first half is automatically clustered as discount payment, the second bit as on-time payment, and so on. So this means that the AI is indeed able to find these payment patterns of customers on its own, and it can do this all the time for your whole portfolio. This means that we can give you early warnings about changes in payment behavior, which is very important. Now, going forward, what is the next steps? The next steps is very clear. It's to apply domain knowledge. No AI model can work to its fullest potential without the proper domain knowledge. If you want to have an intelligent model in the real world, you need domain knowledge. So payments aren't being done after an arbitrary amount of time, but following actual human patterns. Let's say a customer pays a discount, right? If we have a look at the whole portfolio, then you can see for a given invoice, the question, did the customer in the last 12 months take discount, and if yes, how much? You can clearly see that there's a peak at 0%, so customers that never use discount. And then it clearly shows that the other extreme, right, where customers almost always or always use discount, is the next peak, and between them it's very low. So there's a very low amount of customers that sometimes take discount. So you should start using these patterns. Is this a discount taker or is this not a discount user? Next is Weekdays. Of course, it's very clear that nobody's going to pay on the weekend, right? But the AI does not necessarily know of the concept of weekends. We have to give it that information. And there's payment runs. If we look at what weekdays a customer pays their invoices on, and you can see many examples that look like this. So this is one customer where it's clear that this customer always pays invoices on Mondays and Thursdays. And if you do this for the whole data set, we can see that 46% of the customers have one clear day where they pay their invoices, and 11% have 2 days. And then less than half of the customers in this data set don't really have a clear payment run. So they pay on each day on the week on average the same, right? But this is information that we need to have. This is actual domain knowledge that we need to feed into the system to make it even better. And then the same goes for seasonal businesses, fields, large and small customers, the payment type, and there's a lot more domain knowledge that we can use to improve this system even more. So this is where you can benefit from working together with domain experts at SCHUMANN to use the full potential of payment data.
So thank you very much, Nicholas, for the insights, and that's really impressive. And when I saw first time the outcomes of your research, I had the feeling there's so much potential in that for our customers. So customers in various spaces, customers on the corporate side, customers also on the receivables finance side. Very interesting. And I wonder how trade credit insurers would see that, because looking into their payment experiences, I think there is high potential. I would like to ask you the question coming back to volumes. We saw that there are 2.5 something payment items available. On the one hand, and the number of customers, something 15,000. I think the audience is interested in what is the critical number, and I know that this is not easy to answer. I will come back to the question data quality in the second question, but could you give us an idea what is the critical number somehow that it's useful and necessary to train such a system?
Well, unfortunately, it is not so simple. The critical number, so to say, really depends on the specific use case. If there's a very, let's say, you have a group of customers that behave very similarly, right? They always behave very similarly. Then the critical number that is needed to train a system might be quite low. However, if you have a very diverse set of customers, then the amount of data you need to properly train a system to represent all different cases of possible outcomes, because in the future you don't want to only have the system make statements about your data, but you also, of course, you want to go further and get information about new clients, right? Or new things that haven't been looked at by the AI so far. So to make that possible, you need to diversify your data set, of course. And this is why, in this case, we used 2.5 million data points. I think that's a reasonable number if you want to really have a model that is able to make statements about also data that it doesn't necessarily have seen in the training yet, right? I want to add one point. One thing that's very interesting is many of these models, you can actually take a trained model as a baseline and then use your own data to further train it, to further specialize it. And in that case, you need much less data, right? Because it has a general understanding of how these things work, and then you can make certain that it works for your use case by feeding it your own data. So then you need a lot less. But to give you a number, I don't think it's so simple.
Yeah. So, that's so interesting, and it's promising also for the audience to see. There are experiences how to tackle that topic for a certain customer, for a certain portfolio. And of course, data quality is something that is really useful to discuss and investigate a little bit more. In one of the charts, you explained the KPIs. Maybe if you could give us a little bit an idea, what are the key points in terms of data quality that is needed to use that for machine learning and artificial intelligence?
Right. I think the first step that needs to be made sure of is that for all the data points in your data set, you actually have the necessary data, right? Because if you have a very diverse data set, let's say worst case, you use different databases and they have different amounts of data available to them, and maybe someone who's worked with all this can work with it for a long time because they know how it works together. But you need to really make sure that the data is coherent at first. And then I think, to really make a good prediction, the data needs to have the information that you would use as a human as well, right? So let's say if there's a discount date, or maybe even more than one discount date, then this should be reflected in the data. If there was a complaint about something, then it should be reflected in the data. So all the information that is used by a human analyst should be available, because it can also be used by the AI.
Yeah, so thank you very much for all the insights. And I'm looking forward to your research activities and the outcomes that we will see in the future. Fantastic. Thank you very much.